Happy Monday, team. As promised, I'm going to go over the problem that we started on Friday that I did not go over on the weekend because I wanted to give people an opportunity to work with it more. So the practice check is really functioning as a check-in. Do you know how to use a radius? Once you have that piece of information about a circle, could you find all of the other length and area information that I might want about that circle? In this case, we have a circle, and the distance it looks like from the center to the boundary is 5 units. So first off, I need to decide, what is that? Well, what is the circle's radius? I know the radius is the distance from the center to the boundary, so the circle's radius must be 5 units because the radius is shown. Now I want to find the circle's diameter. So we know that the diameter is the distance across the entire circle going through the center. So that means that it goes from the boundary to the center, 5 units, and then from the boundary to the center, another 5 units. So that's going to be 5 times 2, or 10 units. The circumference is the distance all the way around the circle. And we know that the relationship between the diameter and the circumference is through the constant of proportionality, pi. So the circumference is pi times the diameter. So we have C would be pi times 10. And we could write that as 10 pi. Generally, you put the number that's rational before you pi. And then that would be approximately 10 times 3.14, which is approximately 31.4 square units. And the reason it's square units is because when you're looking at the inside of a shape, that's like counting up how many squares are inside that shape. So it's going to be square units. And that goes, oh, I'm so sorry. That was, nope, absolutely not. That's still the circumference, my bad. So the circumference was 31.4. That's still units because you're just measuring a distance, the distance around. Now I'm thinking about area. And I know area is going to be in square units because, like I just said, you're counting up the number of squares that are inside that circle. So for the area, we last week said that if we took pi and multiplied it times r again, which is the same as pi times the radius squared, then in this case our radius is 25, so pi times the radius is 5. Pi times 5 squared would be pi times 25, which we could rewrite as 25 pi square units. And that would be approximately 25 times 3.14, which is going to be approximately, it's going to be in the 70, I think 78 zone. Let's see, if we do 25 times 3.14, we'll get that it's approximately 78.5 square units. So units, this is just length, units, length, units, length around. The only thing that we're going to be thinking about square units is area, because that's now what's inside. We're measuring squares, counting up squares that are inside. Notice that I always started with my exact, like 25 pi, and then ended with my approximate. And the reason I'm doing that is because when you have things exactly, it's sometimes easier to see, are they actually comparable to each other? Are they equivalent? So this was the problem from Friday. We just looked at these 3 images, and I asked you to come up with some questions. And in 7a, I believe it was, which has the, do these have this, take up the same amount of white space? In 7b, it was, which of these takes up the most white space? So not do they have the same, but which one takes up the most space? And in 7a, it was, are these areas equivalent? And when you're asking about taking up space or covering space, and I like covering because we're really thinking about covering this space, that's the same as thinking about area. So we really want to compare the area of these 3 figures. So let's set ourselves up some workspace. Most people ended up gravitating to doing some measurement. Since I gave you no measurements on these, a lot of people said, well, let me measure this side length and see if I can find information about the circle, or measure the diameter. And it ended up being pretty dang close to 8 centimeters for the diameter. And that was 8 centimeters across this square's side length, and also 8 centimeters across this square's side length. So that gave a lot of information that we could use when we're thinking about area. We want to end up with the area. So, like we saw in the practice check, if I want area, it's helpful to have the radius, because I know that I can do pi times r squared to get the radius. So if my diameter is 8, that means that my radius is going to be 4 centimeters. Looking at this, now I have pi times 4 squared, which is the same as pi times 4, which is 16 pi. And that's going to be, since I was talking about centimeters, but I'm looking at the squares inside, what's covered by it, 16 pi square centimeters. And I have one circle, so this is all I need for this one. The area of this one, well, we still have pi r squared, but we will have 4 of them. So it's for each circle. If this is 8 across, then going only halfway across for one circle, that's going to be 4 centimeters, which means that the radius is only going to be 2 centimeters. So I would have pi times 2 squared, which is pi times 2 times 2, which is 4 pi square centimeters. But we have, that's only for each, and we have 4 of them. So we now need to multiply by 4 because we have 4 circles. And we end up again with 16 pi square centimeters. So that's interesting. And most of you ended up saying that these two were equivalent, even when you were looking at it approximately. And it ended up being approximately 50.24 square centimeters. This one, most people said, was different. Close, but a different area. And I want to show you what happens when you do this exactly. So we have 8 centimeters across, but we have 3 circles that we need to split up. So we can take 8 centimeters divided by 3. Well, that's a fraction right there. We can just say that the diameter is 8/3 centimeters. And if our diameter is 8/3, now we want just the radius. So we don't need all 8 of them. We only need half of that. So you could do 8/3 times 1/2, which would give you 8/6. No. That's the same as 4/3. And that's the same as just taking 8/3, cutting that, you now have 4/3 and 4/3 on either side. So we have a radius of 4/3 centimeters. So that was a tangent, a useful tangent. So area is going to be pi times r squared. Area then is going to be pi times 4/3 squared, which is the same as pi times 4/3 times 4/3. And this is, again, for each of the small circles. So I have pi times, well, 4/3 times 4/3. When we multiply, we end up multiplying straight across, so 16/9, or 16/9 pi square centimeters. But we need to do this 9 times because we have 9 circles. Well, if you have 16/9 times 9, well, that's going to be the same as just 16. Because if you do a 9th 9 times, you now get a whole. So 16/9 9 times is going to give you 16 wholes. So we have 16 pi square centimeters once again. And when you do it exactly like this, you can see that in fact all 3 of our areas are the same. When you do it approximately, you end up with something slightly different because you had to approximate this radius. Since 4/3 does not become a terminating decimal, you ended up with like 2.6 repeating here, which then was 1.3 repeating here. And if you stop and say 1.3 or 1.33, you're going to end up with something that is slightly different. It's only going to remain the same if you keep it in fractional form. And that's why it's really useful to keep things exact when possible, and then to keep it exactly with pi, because you can see, oh, all 3 are the same.